This is the second lesson from Chapter 2 on surds and indices, and today we're going to focus on the last three objectives, which is to know the rules of indices, to know the measure of negative, zero and fractional indices, and also to be able to simplify expressions involving indices. So a lot of this stuff is going to be a review from Algebra 2, and I've listed on the board there the different rules that you would have learned. So when you multiply two things with these terms here at the start are called the base. When you look at things with the same base, when we multiply them, what we do is we add the exponents together. And if I skip to the third rule here, that's the same thing if we divide. When we divide, we subtract the exponents. Now, the second rule we often refer to as power to a power rule. So we have one power, then raised to a second power. When that happens, you multiply the two powers together. Anything to the power of 0 is 1. If you have a negative exponent, then that means you do the reciprocal of what it says here. If you have the power of negative 1, then it just means 1 over. If you have a to the power of negative m, then it means you work out a to the power of m, but then you do the reciprocal of that. A to the power of a half means it's a square root, and a to the power of 1 over a particular number means it's that root. So a to the power of 1/3 would be the cube root of a. Also, when we have a to the power of p over q, we've got a couple of ways we can work this out. We can either do a to the power of p to the power of 1 over q, which means we do a to the power of p and then do the qth root. Or we can do the qth root and then raise it to the power of p. Now, there's a good reason why we actually want to do it the second way around for that one in particular. So, for example, if I was to ask you this question, most of you aren't going to know what 16 to the power of 4 is anyway. And, oops, I got that the wrong way around. I'm going to say 5 over 4. Let me switch that around. Most of you aren't going to know 16 to the power of 5, and even if you did, you're not going to know what the fourth root is because that's going to be a very big number. So when we have this, I would recommend that you do roots first, and then do powers second. Because this question we can do perfectly well without the calculator. I'm going to do the fourth root of 16, and then I'm going to raise it to the power of 5. So which number multiplied together 4 times gives us 16? That's going to be 2. And then I've got to work out 2 to the power of 5, which I should figure out fairly quickly, is 32. Now, I can also extend this question as well. If I was to make this 16 to the power of negative 5 over 4, actually it's not that much more difficult. I'm going to work out what I just worked out, and then the negative exponents tells you to do 1 over that answer, so it would just be 1 over 32. Now, another A-specific question for this would be something like this. 2 to the power of 1/4, all raised to the power of negative 3 over 2. Now, you probably didn't do questions like this with mixed numbers like this. So what we actually want to do is we want to change the format. So I'm going to make it into an improper fraction. How I did that, in case you haven't done this for a while, 2 times 4 is 8, add on 1 gives me 9, and I know this question is about quarters, so I put quarters here. So I've got to think what I'm going to do first. I want to do my roots first. So the 2 tells me I'm going to do a square root. So the square root of 9, square root of 4. I then want to cube both numbers. So 3 cubed and 2 cubed. And then the negative tells me I'm going to do the reciprocal. So the answer to this question would be 8 over 27. Notice when I was doing my steps, I didn't put equals here, because this certainly is not equal to this, and this doesn't equal this. This was just my little steps of working out while I was actually doing questions. If you want to see number-specific examples for what we were talking about on that first slide, then these would probably work pretty nicely. Often with numbers, people do make mistakes because they see 2 times 2 and they want to write 4. So just be careful and make sure you stay with the same base when you're doing that. And I think the rest of the rules should be pretty self-explanatory there. Also at the very bottom there is that little reminder that you should do roots first and powers second when you're evaluating your indices. And on the last slide I have here are the questions that I would recommend that you should do. Remember, ACE means keep doing the alternate parts for any questions where relevant. And I've also posted a few websites that I came across in previous years that could give you some extra practice if you need them.